Is this where you learn about geometry?
It sure is, kiddo. Take a seat. This is Hector. Hector is a hexagonal prism. He's a polyhedron.
What's a polyhedron?
A polyhedron is a 3D figure with polygons as faces.
Are there special types?
There sure are, Dan. One type of special polyhedron is a platonic solid. A platonic solid is one of 5 regular polyhedra. A regular tetrahedron, a cube, a regular octahedron, a regular dodecahedron, and a regular icosahedron.
So cool. What's that?
It sure is. This is Euler's theorem. Euler's theorem is that in a polyhedron, the number of faces plus the number of vertices equals the number of edges plus 2.
Alright.
Let's do a problem, Dan.
Alright.
If Hector has 8 faces and 12 vertices, how many edges does he have?
Well, using Euler's theorem, there's 18 edges.
Good job, Dan. Now go learn some geometry.
Yeah, let's go.
Is this class where you learn to pick up girls?
No, this is geometry, the opposite. Now sit down there. So this is Rackle, a rectangular prism.
What's a prism?
A prism is 2 congruent faces called bases that lie in parallel planes.
What's the surface area?
Well, first you have to learn that there are 2 faces that are bases, and then there are lateral faces. Lateral faces of a prism are parallelograms formed by connections from the corresponding vertices of the bases.
So how do you get the surface area then?
The surface area is the sum of the area of its faces. So to find the surface area of a prism, you have to find the area of the base multiplied by 2, and then add the perimeter of the base times the height.
Are we going to do it for Raquel?
Yes.
Well, for the 2 times the area of the base, that'd be 8 feet, plus the perimeter times the height, which would be 4 times 4, which is 16, and 8 plus 16 equals 24 feet.
Sorry, sir, but that is incorrect. The unit used to find surface area is units squared. So the right answer would be 24 feet squared.
And what's that?
Oh, that's the formula to find the surface area of a right cylinder. Surface area equals 2 pi r squared plus 2 pi r h.
Are we going to use that formula today?
No, nobody likes cylinders.
Okay.
Now leave my classroom.
Oh.
Whoa, how are you a teacher?
Don't worry about it. Take a seat. Today's lesson is on pyramids. Here we repeated the pyramid.
What's a pyramid?
A pyramid is a polyhedron in which the base is a polygon and the lateral faces are triangles with a common vertex. The vertex up there.
What's a lateral face?
The lateral face is the triangle on the pyramid. This is the base edge is the side of the base, the height, lateral face, and this is the lateral edge, and this is the slant height.
So, how do you find the surface area of a pyramid?
Well, the surface area is the base, which is the area of the base, plus 1/2 of the perimeter, which is the length around the base, plus the slant height, which is up there. And we're also learning about cones today, so I'll throw it in there. But no one likes cones, just saying. So, the surface area of a cone, which is pi r squared, and r is the radius of the base, of the circle on the base, plus pi times the radius times the lateral sine height.
Thanks, man.
No problem.
Shimona! And are you okay? Is this dance class?
Does this look like dance class to you? We're learning about the volumes of prisms and cylinders. First, we're going to start off with the prism. To find the volume of the prism, you have to take the base times the height. For the cylinder, it's the same. It's almost the same exact thing. Except for the area of the base, you can substitute pi r squared, the area of the circle. For a cube, you can find the volume by taking the side length and cubing it.
Ooh. Seems a lot better than dance class.
Yes, very. It is. There's also another principle called Cavalier's principle. It states that if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. There are also many other postulates, such as the volume congruence postulate and the volume addition postulate. The volume congruence postulate states that if two polyhedra are congruent, then they have the same volume. The volume addition postulate states that the volume of a solid is the sum of the volumes of all its non-overlapping parts.
It's a lot.
Better than dance class, isn't it?
So much.
Ooh, just came back from a workout. Give it to me straight. How big these guns?
Well, they're pretty big, but are you ready to work out your mind?
I'm down.
Alright. Today we're learning about the volume of pyramids and cones. They're pretty simple. The volume of a pyramid is 1/3 the base times the height. And the volume of a cone is 1/3 pi r squared times the height.
Man, that's so cool.
It is cool. It's cooler than working out.
I don't know about that.
Alright.
Sir, would you like to teach me how to play guitar?
My pleasure.
Let's go.
Do you want to take a ride on the magic carpet? Sir, we're learning about spheres today.
Well, that sounds pretty cool.
Here's a textbook. Please read out loud what the definition of a sphere is.
A sphere is the set of all points in space equidistant from a given point.
Yes. And can you read what a chord is?
A chord of a sphere is a segment whose endpoints are on the sphere.
And what is a radius?
A radius of a sphere is a segment from the center to a point on the sphere.
And what is the diameter?
A diameter of a sphere is a chord that contains the center.
Now you're ready for the surface area and the volume of the sphere.
Yeah!
Surface area. Surface area equals 4 pi r squared. You need to multiply by 4 because if it was a baseball, you can rip it apart and it would be 4 circles, or just about. Now the volume. Volume equals 4/3 pi r cubed. Any questions?
That sounds pretty interesting.
So Eric, what have we learned about... Hey, what are you doing here? Late for class again? Detention, 3:05 in the afternoon.
What? I don't like this concert way. I'm out. Fashionably late, as usual. So, what are we learning today?
Today, Daniel, take a seat. we are learning about similar solids. Two solids with equal ratios of corresponding linear measures are similar. The similar solids also have factors. The scale factor is A to B, and then the area ratio is A squared to B squared, and the volume ratio is A cubed to B cubed.
Alright. Thanks, teach.
Wait. 200 times. Oh, right, why I will not be late for class.
The radius of the basketball is 6 inches. The surface area equals 4 pi r squared. So S equals 4 pi 6 squared, which is 144 pi inches squared.
The radius of the cone is 3 centimeters, and the slant height is 10 centimeters. The surface area is pi r squared plus pi r L. So, the surface area is equal to pi times 3 squared plus pi times 3 times 10. The surface area is 9 pi plus 30 pi, which equals 39 pi centimeters squared.
The height of the box is 4 centimeters tall, and the length is 15 centimeters. The width is 10 centimeters, so the volume equals width times height times length. So it's 10 times 15 times 4, which equals 600 centimeters cubed.
The height of the cylinder is 20 centimeters, and the radius is 8 centimeters. The volume of the cylinder is pi r squared h. So the volume equals pi 8 squared times 20, which equals 1,280 pi centimeters cubed.
Try.
No, it's scary.
Mohan, you try.
Hey, Mohan, grab on this. Mohan, follow me, Mohan. Alright, ready? Go. Mohan, walk backwards. Oh, it's broken!
It's not broken, you're just not doing.
Multiplied by the lateral edge of the left side.